So for question 7, the diagram shows a parallelogram OACB, where OA is given by the vector 2i plus 4j, OB is given by the vector 4i minus 3j. Show that cos of AOB, so that's just this angle here, I'm just going to call it x3, cos of this angle here equals this. Now to do that, I am not going to start doing it, right, in order to think about how to do this, this is a really good indication that you're going to need to use the cosine rule. Now, to use the cosine rule, you either need to know all 3 sides or you need to know 2 sides of an angle. We will have enough information to know all 3 sides just here, because we can work out this vector, which is A to B. Now, to get from A to B, let's just work out what we're going to do. So to get from A to B, well, we're going to go down this route. So going down that route is going to be minus 2i minus 4j. And then we're going to go down this route, which is plus 4i minus 3j. And so then if we simplify that, minus 2i plus 4i is 2i, minus 4j minus 3j is minus 7j. So this as a vector is 2i minus 7j. Now you do not want to start substituting these vectors into the cosine rule. It's going to become really complicated. And so what we can do is we can work out the magnitude of each vector. Now to work out the magnitude of each vector, you're using Pythagoras' theorem. So to work out the magnitude of OA, all we are doing is 2 squared plus 4 squared and then square rooted. Do not turn this into a decimal, that would be like a weird thing to do. So if you do that, 2 squared plus 4 squared square rooted, you get that OA is 2 root 5. I'm just going to go and write this up on my diagram somewhere. 2 root 5. We can do the same thing for OB, which is going to be 4 squared plus 3 squared, which is just 5. And then finally we can do the same thing for AB. So AB is going to be 2 squared plus 7 squared, which is root 53. Right. And now you've got all 3 sides, you've got enough information to use the cosine rule, because the cosine rule says that a squared equals b squared plus c squared minus 2bc cos a, like that. Now don't worry too much about the a's, the b's and the c's. Crucially, it's saying that one side equals the other 2 sides squared added together minus the other 2 sides multiplied together times cos of the angle between them. So in this case, a squared is going to be root 53. So root 53 squared equals the other 2 sides squared. So 2 root 5 squared plus 5 squared minus 2 times by 2 root 5 times by, let's get this right, 5 times by cos of my angle, which in my case I've just called x because it seems slightly easier. Now when it comes to sort of sorting this out a bit, well, root 53 squared is 53, 2 root 5 squared is 20, 5 squared is 25, minus 2 times 5 is 10, 10 times 2 root 5 is 20 root 5, cos x, like that. We can solve this a little bit more, so we're going to get 53 equals 45 minus, I can't write anymore, my pen's gone weird. Let's just write this out again. So what we're going to get is we're going to get 53 equals 45 minus 20 root 5 cos x. We can then, what can we do now is we can take away this 45 from both sides. So when we do that, we get 8 equals minus 20 root 5 cos x. And then here, I'm just going to write up here because I'm running out of space. We can then divide both sides by 20 minus 20 root 5. And so we're going to get cos of x equals 8 over minus 20 root 5. To simplify this, you can times top and bottom by root 5 over root 5. And when you do that and use your calculator to help with this final bit of simplifying, you get cos of x equals minus 2 root 5 over 25, which is the thing that we were aiming to get to in the first place. After that, B. So part B is a hence. And so even if you couldn't do part A, you should be able to have a go at part B. Find the exact value of sine AOB. The common mistake that loads of people made is they put this into their calculator and then started putting sine into their calculator. It doesn't work. It's not going to give you an exact value. And so what is useful to remember at this stage is this identity, that sine squared x plus cos squared x equals 1, like that. And so then when we do this, we also know that cos squared x equals 1 minus sine squared x. Cos x is this. So cos squared x is going to be minus 2 root 5 over 25 squared, like that, equals 1 minus sine squared x. I've sort of written this really awkwardly. I don't know why I've done it like this, but let's just go with it for now. So if we work that out, so minus 2 root 5 divided by 25 squared gives this. It gives 4 over 125 equals 1 minus sine squared x. We can therefore get that 1 minus 4 over 125 equals sine squared x, like that. 1 minus this is 121 over 125 equals sine squared x. And so finally, because that's sine squared x, to get to sine x, we can just square root both sides. If you square root both sides, you can use your calculator here. You get 11 root 5 over 125, which is the answer we were looking for. Finally, for part C, we want to determine the area of this parallelogram. Now, with a parallelogram, we know that a parallelogram consists of two triangles. And to work out the area of a non-right angled triangle, the formula that you would use if we call this triangle 1 is half times A times B times sine C. And so what we're going to do is we're going to do half times side A, which earlier we worked out was 2 root 5, times by B, which earlier we worked out was 5, times sine of C, where C is 11 root 5. Oh, wait, ignore that, sorry. Let me just rub that out. Sine C we worked out in part B of the question, so just skip back a bit if you can't remember what that was. But sine C is 11 root 5 over 25. Like this. So if we work that out on our calculator now, we get this answer, which is 11. Now you might be tempted to stop there and say that the area is 11 units squared. That would be wrong, because this shape actually consists of two triangles, this triangle here and this triangle here, which are both the same because it's a parallelogram. So we just need to times that by 2, giving a final answer of 22 units squared.